Hello everyone, and this is finding point of intersection through the method of substitution. So this is a part of the iBuddy series program, and this is a section of the Unit 5 part, which covers essentially point of intersection, linear equations, elimination, decomposition, in general, the methods. So what exactly is the point of intersection? So we've covered this in earlier videos, but I'm just going to draw a graph here. Essentially, you can see this is a grid, and if we have one line going down here and one line going down here, in the test or on the exam, they'll give you one formula or one linear equation that correlates to one of the lines, and then another linear formula that correlates to the other. And your job here is to find the exact point in which they both intersect. That is what substitution is used for. So in general, substitution is a very important concept, and the name is exactly as it implies. The method involves taking one variable and then isolating it on one side, and then plugging that thing back into the second formula. So at first it might sound a bit complicated, but we have an equation right here to begin our work. So I'll switch colors first. So as you can see, we have two equations as I listed here. X plus 4y equals 6. 2x minus 3y equals 1. So how do you solve these equations and find the point of intersection between them? So as you can see here, x plus 4y equals 6 is far simpler in terms of variables and numbers than the second equation, which is 2x minus 3y. And what you want to do here is you see here, x is completely isolated without any reciprocal, and because of this, it's far easier to do substitution with this specific equation. Now, you could do it with the second equation, but simply the first equation will save you a lot more time, and that's what you're aiming for in IB. So as you can see, we want to isolate this, and in order to isolate it, we're going to have to remove the 4y from one point and move it to the other side. Now I'm going to change colors. Minus 4y, as you can see here, equals 6 minus 4y. Now, with this, we've essentially isolated x as to 6 minus 4y, and then this is our equation for the x value. Now, we are not complete. We may have found the x value, but we need to find the specific numbers that correlate to the x value. And in order to do that, I'm going to switch colors first. In order to do that, we have x minus 6 minus 4y, and we know that x equals 6 minus 4y. And thus, what we want to do is we want to take the second equation here, 2 6 minus 4y minus 3y equals 1. Now, we've essentially plugged the x back in to the equation. And essentially what you can see here that's really peculiar is that there's only one variable in this entire equation. And thus, you can begin solving for y. So what you want to do first is you want to expand this first. So you have 12 minus 8y minus 3y equals 1. Now, as I've said, you must isolate y and to solve for y. So we have negative 8y minus 3y. 12 minus 11y equals 1. And now we have to take away the 12. Negative 11y equals 1 minus 12. And now we're going to go to the negative 11y equals negative 11. And as you can see here, we can divide both sides by negative 11. And thus we get y equals 1. So now we know that the y value is 1. But we are not done. Let's switch colors here. What we know is that this is not a good marker. What we know is that x and y, we know that y equals 1. So we already know half of the point of intersection. Now what we want to do is we want to take this y value and we want to plug it back into the simple equation to find the x value. I'm going to switch colors here. We have x plus 4, 1 equals 6. And we know that's just 4. No, that this is just 4. So x plus 4 minus 4 equals 6 minus 4. And hold on, I'm going to shift camera down a bit. X minus 4. And what we can see here is that we've essentially isolated for x, and x equals 2. So this is going to be our second answer. So take it in slowly and look at this. Look at what we've done so far. We've essentially taken one of the equations, found out what x specifically is, and found the equation for x, plug that back into the second equation, as I've said before, here in black, and then solved for y. Now, once we had the y value, we plugged it back in to find the x value. And thus, in the end, what we've achieved is a complete set of coordinates which essentially correspond to the point of intersection. So if you were to graph this, say on a test, you're going to graph 2 and 1. 2 is your x value and 1 is your y value. And thus, you've completely found the point of intersection and solved the linear equation. Now, as another example, alright, so this is the second equation we've gotten as a linear equation problem, and we want to solve this using substitution. In essence, if you take a quick look onto these two equations, you'll instantly see that x is already equivalent to one equation. So we'll just take that out here. X equals negative 4y plus 5. In essence, this is the equation for x, and unlike this, unlike the one previously, we can just plug this back in. So I'll just switch colors real quick here. X plus 2y negative 4 plus y 5 plus 2y equals 7. So I have a not so good marker here, and also 1y here. Sorry guys. So what you can see here now is that we've only have one variable across the entire equation, and thus we can continue to solve for y. So what I'll do now is I'll just remove these brackets because, well, they're just there for show. It won't change anything. And we get negative 2y plus 5 equals 7. Since negative 4y plus 2y equals negative 2y. So then we want to isolate y. So we move the 5 over. And in order to do that, you have to do minus 5 from both sides. You have negative 2y equals, well, same again, 2. So in essence, what you have here is another negative 2y, y equals negative 1. And this is going to be your equation for y. So once again, like last time, I'll begin putting this in. So x is unknown and y is negative 1. Now switch colors. As you already know, we're going to plug this back into a simpler equation, and x plus 2 negative 1 equals 7. So x minus 2, since 2 times negative 1 is negative 2, equals 7. And now what we can do is we can isolate for x. X thus equals 9. So the complete equation we have here is 9 and 1. And as I've said before, what you can do is, if you're going to plot this on a graph, right, you're going to plot 9, negative 1, and then label that as 9, negative 1. And you've essentially solved the equation. So, this is, of course, the third and final equation. And I thought it'd be nice to tackle a word problem in this format. And so for my bad handwriting, what it says is that Samantha works twice as many hours as Aram. The total hours is 39 per week. So if you can't see that properly, it's 39. And in essence, what we want to do here is, first off, we want to compile this into one linear equation. So in IB, what you want to do first in any word problem is to start with your let statements. So what is a let statement? Of course, you're going to basically assign variables to whatever you want to find out, or whatever subjects you may have in the equation. So I'll quickly demonstrate here. We have Samantha. Let S be Samantha's hours. And let A be Aram's hours. So I'm gonna start a bit left this time in order to save some space, but essentially we have representations and variables for each of the subjects in the question, which is Samantha and Aram. So now it's time for us to question, what exactly do we need to know from the equation? And we know that Samantha has twice as many hours as Aram. So S equals 2A. And what we also know is that the total hours in general is 39 per week. So we know that S plus A is 39. And as you can see here, we basically have a linear equation. X equals 2A, S plus A equals 39. And this is a perfect example of what we would do for substitution, as we already have X equals 2A. And all we have to do now is we have to plug in 2A into the second equation. So I'll quickly do this and switch colors. So as we know, S equals 2A, which means that 2A plus A equals 39. This is S plugged in because S equals 2A. So knowing this, we can quickly solve this. 3A equals 39, as you can see. And now it comes to multiplication and division. Of course, you should know what to do. Divide both sides by 3 in order to eliminate the 3 and to isolate for A, which means that A equals 13. So this is our A value. And I'm going to save space here for the later parts. What we essentially know is that the point of intersection, or the amount of hours that Aram works, is 13 hours. So I won't exactly write that here. But if you were to represent this as a linear equation, then the x value of the point of intersection would be either x or y value of the point of intersection would be 13. So I won't exactly write this here because there's really no need. It doesn't really answer the question. But in order to solve for Samantha's hours, as you can see perfectly here, S equals 2A. S equals 2, 13, and thus S equals 26. Now you have Samantha's hours. So, I know the question here doesn't explicitly state which one you should be solving for, but if it says that, for example, if it says, how many hours does Samantha and Aram work, you'd have to put in a let statement, which I'll nicely show you here. Let, therefore, this is a therefore sign, Samantha works 26 hours and Aram works 13 hours a week. That is how you'd write your therefore statement. And if you did all of this, then essentially you've gotten 10 out of 10 marks and finished the equation. So that will be all for finding point of intersection through substitution. And in the later stages, you'll probably learn more sophisticated ways to do this and actual techniques which help you skip to the final answer. But that's mostly in grade 10 and grade 11. In general, I'll just end the video off here. That's how you find the point of intersection through substitution.